Okay, in this video we'll cover power distribution and how the battery and the alternator and the rest of the car all connect. And it's all right here and the underhood fuse box. Now I picked this particular car. This is a model Honda, has a fuse box real close to the battery, so it's really easy to understand. You'll see obviously 12-volt storage batteries here. This is going to operate the car. All the power comes from here if the car is not running, or could actually pull power from here if the alternator can't keep up, which it should, but there may be a scenario where there's a lot of extra load on the car and low RPM. Here's our 12-volt storage battery. Over there on the far corner of the engine is the alternator, and the post is easy to see. It's on the very top. If you look at the alternator, see one big post. It's going to be like a 1/4-inch bolt, a 6mm bolt. It'll be a big bolt with a nut on it, and that's the output of the alternator. You'll see in a second, the output of the alternator over there comes back around to this underhood fuse box, and so does the positive post of battery. So let's get this lid off here and take a look. Yep. So if you look right here, there's two big screws, and if you look down the side here, I'd have to move the camera to show you, but the output of this big heavy gauged white wire on Honda's, white wire means hot from the battery. It's going to come through this conduit. It comes up right here. So this post is directly connected to the battery. This post is another big white cable that runs around and goes over to the output of the alternator. So the output of the alternator, which is also a white wire, because it connects directly to the battery. That's kind of the color scheme in the Honda world. So the output post of the alternator goes directly to the positive post of the battery. Sometimes you'll find, matter of fact, it's actually, there's a 100-amp fuse underneath this bar here. So they do run through a fuse, 100 amps, in case something goes terribly wrong, like that wire gets pinched to ground over there. But a lot of models, there's no fuse here. Most cars, the output wire on the alternator is directly hooked to the positive post of the battery. So one thing to learn from this, we always want to disconnect the battery before we disconnect the alternator. You may have this car in the air and you've got the alternator on the bottom side. You disconnect the output wire, pull it off, and it just let go. It swings over, touches the ground, and you'd be lucky if you don't burn the car to the ground. If that gets to the ground somewhere and you can't get to it and get it off, it's going to melt the wire all the way back to the battery. So always disconnect the battery, and always disconnect. The safe thing to do is the negative first. If I'm on a positive post with a wrench and a ring, I'm standing here and the ring happens to get to ground, I created a circuit right through my wrench, my ring to ground, infinite current theoretically, because I have a dead short, and the ring becomes a branding iron. And there's horror stories out there. You have to go to the emergency room, get it cut off, and you'll be scarred for life with a big burnout hunk of meat on your finger. So anyway, negative post not a problem. I'm disconnecting the negative first. I touch ground through a ring, no problem. Ground. Once this comes off, then that one's dead. So anyway, this is where the output of the battery comes in the fuse box. This is where the output of the alternator comes in. They're hooked together and they feed this fuse box, which feeds the whole car. This is ground zero for the electrical system. So like I say, the battery and alternator are both, think of those two as coming in joint onto the same feed and into here. So a little scenario, just walk through about 3 different scenarios. If the alternator is not working, the belt come off, alternator's failed, or the car's not running, all power comes to the battery. From the battery into the fuse box, and then to run the car. So I can run the car off the battery, but after a short period of time, the battery's going to be depleted, and we're walking. Now, crank the car up, and the alternator starts charging. Now, this nominally is about 12.5 volts or so. The alternator will put out higher voltage than the battery, therefore current goes back into the battery. So you crank the car up until the alternator starts, all the power is coming off of this leg from the battery, from battery to the fuse box to the car. Get the car running, the alternator starts doing its thing. Now the alternator feeds the fuse box, the whole car, and recharges the battery. So soon after you crank the car up, as soon as the car starts running, you'll have current going back into the battery to replenish the last time you just cranked the car up. Now the battery, once it attains full state of charge, it's a chemical thing, but it's kind of cool how it works. Is its resistance or its ability to take a charge will rise, and by the time this battery is at full state of charge, there'll be very little current going into it anymore. It kind of regulates itself. But now, so if you're riding down the road and all is well, you'll be all the power is coming from the alternator, feeds the box, feeds the car. Very little is trickling to the battery to keep it charged. If something happens to the alternator and it can't keep up, if the voltage starts to drop at a certain point, then it'll start pulling from the battery and the alternator, and both feed the fuse box to run the car. You say you've hung a lot of electrical stuff, you've outpaced the output of the alternator, you've got a humongous radio system, whatever you got, and now you're slamming the alternator and it can't maintain the minimal voltage, and it's dropped down to where the battery now is up. At that point, you're going to be walking pretty soon if you don't get the car, something turned off on the car. So another thing too, the alternator is not designed to run at 100% capacity. Actually, Napa, I think, did a big study on this many years ago at one of those seminars, where if a car comes in, the alternator quits charging, the battery's probably dead. And they found out people bad about, they diagnosed real quick, need an alternator. Well, alternator, but they don't take time to charge the battery up. Stick the alternator on the car. Maybe even jump the car off and tell the customer, hey, make sure you don't cut it off about an hour, which is not a good way to do business. Maybe somebody driving the car and the car cuts off and now they're stranded. But they found that they were having a tremendous amount of alternator failures, and they traced it back to shops that weren't charging the battery before to put the car back on the road. So the alternator wasn't designed to be a big commercial grade battery charger and also run the car. So if you're in the business of working on cars and changing out alternators, be sure and you use a battery charger to charge the battery, the full state of charge before it goes back out, because you don't put your customer in a car, the battery's not fully charged and they have trouble cranking the car and they're stranded again. And the alternator over there is going to take a punch and could have a shorter lifespan, because the first 2 or 3 hours of its existence it was trying to run the car and charge the battery at the same time, and will have a premature death. All right, that's a wrap on how power is distributed between the alternator, the battery, and the main fuse box, and the car.